Hi, this is Nathan Tintle. In this learning goal video, we're going to talk about how the idea of confidence level corresponds to coverage probability. We'll use the Affordable Care Act data set to talk about this learning goal. So a common question we hear is, what does 95% confidence really mean? Here's what it means. If we took repeated samples from the population, computed a confidence interval on the data from each sample, then 95% of the confidence intervals we would get would contain the population proportion. Let me show you an example. Let's imagine that the true proportion of all Americans who said they were not affected by the Affordable Care Act is actually 70%. Now that would require doing a census, but let's just imagine for a moment that that's true. Pi, the proportion in the population, is 70%. Now, when I take a random sample of people from this population of all U.S. adults, I'm going to get a sample proportion close to 70%, but not exactly 70%. Every sample will be a little bit different. So let's start taking some samples. So here are a set of 5 samples that we took. So we're now sampling 1,034 adults from a population where we know the true proportion of all people who say they weren't affected by the Affordable Care Act is 70%. First sample, p-hat is 69%. 69% of this sample said they were not affected by the Affordable Care Act. You see, you get the corresponding 95% confidence interval there, and it includes 70%. Now, the second sample, you get a p-hat, you get a confidence interval. That confidence interval includes 70%. That's a good thing, right? Because the true parameter is 70%. We're hoping it's in our confidence interval. That's why we're doing this. Sample number 3, 70% is in there. Sample number 4, 70% is in there. Sample number 5, 70% is in there. This is looking pretty good. We go to sample 6, it's in there. 7, it's in there. 8, it's in there. Oh, sample number 9. Sample number 9, 73% of the people in the sample said they were not affected by the Affordable Care Act. Now remember, this sample is coming from the same population where we know 70% of people say, out of everyone in the population, 70% say they've not been affected by the Affordable Care Act. This confidence interval does not include 70%. So what does this mean? This helps us understand this key idea. If you took repeated random samples, just like we were doing, 95% of the confidence intervals would include the true parameter value. That's what 95% confidence means. And, you can translate that to 90% or 99% as well. Whatever your confidence level is, that percent of confidence intervals across many random samples from that population will include the true parameter value. Now here's a word of caution. Because of this interpretation, strictly speaking, we shouldn't say there's a 95% chance that the parameter is in the interval. See, the parameter is a fixed value, like in that example we just talked about. 70% of the population said that the Affordable Care Act had no effect on them. It's the interval that's random because each random sample is a little bit different. So this is a subtle point, but this is why statisticians say confidence and not chance. So we're not saying it's a 95% chance interval, it's a 95% confidence interval, and we use that word confidence to mean, well, what we just talked about. If we take lots of random samples, that percent of the confidence intervals will include the parameter.